continue with our discussion on the psychrometric processes which are common in air conditioning application. And if you remember, we were discussing regarding the bypass factor of a cooling coil. What I told that a cooling coil, it is a heat exchanger surface, and basically it is a cross flow heat exchanger where we will have the flow of refrigerant, cold refrigerant through the inside of the coil, and it makes the coil cool at a very low temperature, and air passes over the external surface of the coil. So, the air which comes in contact with the cooling coil, that will attain its dew point temperature. Now, there is a certain mass flow of air past the coil or across the coil. Obviously, the entire amount of air will not come to the surface temperature, will not come down to the surface temperature of the cooling coil. Okay. If the surface temperature of the cooling coil is Ts, and if the air temperature, if the temperature of air with which it enters the cooling coil is Ta, then the temperature of the outgoing air will be somewhere in between Ts and Ta. Okay. So, this process is idealized in a different manner in air conditioning. It is assumed that certain portion of the air makes perfect contact with cooling coil and it has a temperature of Ts, while the other portion of air or the rest of the air does not contact the cooling coil at all. So, it has a temperature Ta itself. Then there is mixture of these two air stream. So, we will have the condition of the air at the exit. On a psychrometric chart, if we represent the process, we will have something like this. Let us say this is the this is the dew point temperature of the cooling coil. It is known as apparatus dew point temperature, and generally it is represented by S because it is at a saturated condition. And let us say this is the temperature at which, or this is the condition at which the air is drawn from outside to the cooling coil. So, this condition, okay, we can represent it by any suitable notation. Let us say we are indicating it as O1. So, we are assuming that certain air is there at condition 1 and another stream of air is there at condition S. These two streams of air are mixing adiabatically to give condition 2, which is the actual exit condition of air. If we represent it schematically, so let us say this is your cooling coil. This is where refrigerant is entering, this is where refrigerant is coming out, and then it is air is entering at condition 1, air is going out at condition 2, and everywhere on the body of the cooling coil we have got condition S. All right. So, one can have this is Ts, this is T2 and this is T1. Similarly, one can have Ws, W2 and W1. So, bypass factor generally it is represented by capital X is equal to T2 minus Ts by T1 minus Ts. It can be obtained of course by this one, that is W2 minus Ws, W1 minus Ws. So, this is the amount of air which is bypassing the coil divided by the total amount of air. So, the coil bypass factor, it depends on number of parameters. So, one can write bypass factor, or sometimes it is called coil bypass factor, it depends on number of parameters, depends on a number of parameters. What are these parameters? These parameters are generally coil design. So, in the coil design, the diameter of the coil, then the number of passes of the coil. So, those things will come. Then fin specification, this is very important, whether you have got only a few fins or you have got large number of fins very closely spaced, what is the fin material, etc. So, that is important, and the air velocity. So, on this parameter the bypass factor depends. So, obviously, if you have got very compact coil, that means if you have got large number of tube turns, large number of fins of highly conducting material, and if you have got high air velocity, you will have a low bypass factor. All right. Whereas, if air velocity is low and the fin density is not high, then one can expect a high bypass factor. So, this bypass factor generally it is specified by the manufacturer of the cooling coil, all right, and obviously it is a parameter which one needs for design and estimation. Now, knowing the bypass factor and of course, the apparatus dew point temperature and the temperature of the incoming air, one can determine what will be the temperature of the outgoing air, how much moisture will get separated. So, these useful quantities can be determined knowing the bypass factor of the cooling coil. All right. Then we are going for the analysis of summer air conditioning. So, as I have told that I like to discuss air conditioning process for different situation. That means, though there could be year around air conditioning system, but the processes of air conditioning for summer and winter they are different, and let us first discuss the summer air conditioning. So, summer air conditioning particularly for hot and humid climate, which is the situation in a large number of places in India. So, we will have a cooling coil through which we will have evaporating refrigerant. So, basically then we should have a vapor compression refrigeration system. The evaporator of it will be used as the cooling and dehumidifying coil. Okay. So, summer air conditioning, let us see how one can achieve summer air conditioning for hot and humid climate. Let us say the condition of the cooling coil, that is apparatus dew point temperature is somewhere here. The comfort condition, okay, comfort condition will be somewhere here, all right, and then the outside air condition is somewhere here, high temperature, high humidity, outside air condition will be somewhere here, all right. So, basically what is done, let me draw a figure, schematic diagram, then it will be understandable. We will have a room, this is the room. Now, in the room cold and dry air will be supplied, all right. This is the room where cold and dry air will be supplied. So, obviously, this air has to come from a cooler or cooling and dehumidifying coil. So, to have this, one should have a fan, okay. One should have a fan, and then of course, from the room this air has to be extracted. Part of it will go to atmosphere and part of it will be recirculated back. Then from the open atmosphere one has to take certain amount of air. Generally, in this path one will have dampers to control the volume flow. So, one can have number of dampers. Okay. This is how one can show schematically the arrangement. So, I can this is called supply air SA, this is the return air RA, this is exhaust air, let us say EA, this is recirculated air REA, this is fresh air FA, all right. And we can give different other names also, 1, 2, 3. I have drawn a very simple diagram. 1 is room, and then 2 is cooler, then 3 is fan. So, only these few things I have shown. There could be number of other items which we will discuss later on. So, this process, this is a summer air conditioning process which I like to also describe with the help of the psychrometric chart. So, one is the room, and well, let us also represent the room air condition as 1. Room air condition as 1. Actually, it is like this. I have told this as the comfort condition. If you remember, while I was describing this diagram, I told this thing that it is the comfort condition. It is like this. When we supply cold air to the room or to the conditioned space, we supply it at a very low temperature and at a very low humidity, low absolute humidity or low humidity ratio. Okay. At a very low temperature and at a very low humidity, we supply the air. That is obvious. We have got our experience that if we stand just beside the exhaust of the air conditioner, we feel the gust of the air which is coming out of the air conditioner to the room, and the air is cold enough. It is not comfortable, it is cold enough. So, we have to supply cold air, because inside the room there is enough heat load, we have to pick it up. So, that is why you have to supply cold air. But where the human beings or where the occupants are there, when the air comes to that place, it will be at the comfort condition, or it should attain the comfort condition. And it is also assumed when the air will go out of the room, it is having the comfort condition. That means, the air which goes out of the room, that is having the properties corresponding to the comfort condition. That means, if we design the room air conditioner, room air conditioning system for let us say 25 degree Celsius or 26 degree Celsius and 60% relative humidity. So, the air which will be going out of the room, that will also have 26 degree Celsius and 60% relative humidity. All right. So, this will be the room air condition, and it will also be the condition of the air which is leaving the room. So, here what we can see, part of the room air is taken for recirculation and it is mixed with fresh air, which is nothing but outside air. So, this is fresh air. So, if these two air streams mix together, then we will have the mixture condition somewhere in between. Okay. Somewhere in between. So, this air will now pass through the cooling coil. So, something like this. This air will now pass through the cooling coil, and then it will be somewhere here. This is this cooling coil has some sort of a bypass factor. So, the supply air condition will be somewhere here, and it will go to the room. So, when this air, which, well, how to represent it, let us 2 and let us say this is 3. So, we can, for this diagram, let us say this is temperature T and omega. So, we can call 1 room air, 2, this is this is recirculated air which is again being recirculated over the machine. So, let us call it mixture of recirculated air plus fresh air. Okay. So, recirculated air plus fresh air, all right. This is the condition 2. Then 3 is the supply air SA. So, what we can see 2 to 3, that is a cooling and dehumidifying process which is taking place in the cooling coil. Okay. The recirculated air plus the fresh air, that mixture goes through the cooling coil and experiences a cooling and dehumidifying process. Then it is supplied to the room. In the room, it undergoes a heating and humidification process. So, in the room itself, in general, there will be both sensible load and latent load. This will be picked up by the air. So, we will have heating plus humidification when the air will pass through the room. All right. And obviously, there will be mixture of fresh air and recirculated air, and when it will go to the machine, when it will be supplied to the machine or cooling coil, it will have a still higher temperature and higher absolute humidity. That is what we will have in our summer air conditioning. The recirculated air, actually this comes in the details of the air conditioning. Why it is needed? Recirculated, first thing that okay, inside human being will be there. So, due to their respiration, one will have depletion of oxygen and increase in carbon dioxide, but recirculated air, the need for recirculated air is not only for that, but also there is generation of staleness inside the room, and so air has to be freshened up. So, that is why it has to be certain amount of air has to be put outside as exhaust, and instead we have to take some amount of fresh air. Okay. So, that is what we have got in summer air conditioning. But here you see, in the summer air conditioning mainly we have got one equipment, that is your cooling and dehumidifying coil. We have got only one process, this is 2 to 3. By this process we are controlling both temperature and humidity. Okay. So, obviously, this task sometimes becomes very difficult. Okay. Sometimes it is like this, that the, let us say it is rainy season, things like that, and outside air is heavily loaded with moisture. So, we have got lot of moisture, we have to get rid of it. So, what we can do? Then we have to cool the air to a very low degree, or the apparatus dew point temperature will be very, very low. If the apparatus dew point temperature is very, very low, then only this is the condition of air W2 and this is Ws, or let us say taking the bypass factor into consideration. So, this is W3. So, W2 minus W3, that has to be quite large, or in other words W2 is fixed, we have to make W3 very large. That happens in number of cases when we are having lot of moisture in the air which goes through the cooling coil, or maybe inside the room itself it has to pick up lot of latent heat. Inside the room it will pick up lot of moisture. So, in those cases it happens. So, we have to lower down the dew point temperature. If we lower down the dew point temperature, we can get rid of moisture, but at the same time the supply air temperature will also fall down. That may not be permissible, or that may not agree with our comfort condition. So, what we have to do there? Then we have to, after getting rid of the moisture, we have to go for heating the air. This is called reheating of air. All right. So, in summer air conditioning, particularly when it is highly humid condition, we have to go for reheating. Reheat control, sometimes it is called reheat control. Why it is called reheat control? Because we are controlling the temperature, okay? We are controlling the temperature of the supply air by the process of reheating. That is why it is called reheat control. So, well, let me draw the psychrometric diagram first, and then we will go for the other diagram. So, basically this is apparatus dew point temperature, this is where air will be supplied. Now, from here we will have a reheat process, which means we will have increase in temperature without any change in the humidity. Then we will have change in the room where both temperature and humidity will increase. Then we will have outside air condition OA, and this is 2. So, we can have 1, 2, let us call it 3, let us call it 4. 3 to 4 is the reheat condition. And if we want to represent it schematically, we will have the room, supply air, then part of it will go out, rest will be taken as recirculated air, it will be mixed with fresh air. Then we are having the fan, we can have the cooling coil, we can have the reheater RH, then the air will go like this. So, what we can have here, this is outside air OA, and we are, well, room air is coming at condition O1. So, this is O1, this is O1, O1 and OA are mixing, it is giving 2. So, here it is 3 and here it is 4. So, this is what we will get in a physical system. Now, please.
Assuming that there is no much of temperature difference in the room.
No, we are not assuming. So, you are asking that whether we are assuming that when in the room the temperature difference is less, but there is no need of assuming it. Only what I am telling that from the comfort requirement we need to supply the air at certain temperature, okay. And also that is necessary because the room has got certain load, okay. So, it is also necessary to supply it at a particular temperature. Now, what happens sometimes particularly during humid climate, we can have lot of humid load, okay. Lot of humid load we can have. So, in that case to take care of this humid load one has to overcool the air, so that some good amount of moisture can be separated out. Now, if we do that we overcool the air also, that means its temperature is lowered to a very large extent. That may not be practicable. So, that is why we have some method for balancing it. We heat the air after it is being cooled or after the moisture is being separated, we heat the air. This process is known as reheating. This heater is known as a reheater. One can look into the whole situation from a different angle. Already I have introduced sensible heat factor, okay. So, sensible heat factor SHF, that is equal to sensible heat load SHL, we call it sensible heat load, divided by sensible heat load plus latent heat load, all right. So, sometimes what happens, if the latent heat load is very high, then the sensible heat factor becomes very low. Now, for all the processes there is some permissible value of sensible heat factor, but our latent heat load is so large that it is lowering down and it is bringing it below the permissible level of sensible heat factor. Then artificially I have to bring the sensible heat factor to the acceptable value. So, what I can do? I can introduce artificially some amount of sensible heating. That is what has been done by reheating process. Clear?
There must be a certain level at which this facility is used. That means the humidity level has to be a certain level.
Yeah, when humidity is very high, then only we can do.
What is that high level?
Actually, this all depends on, it is number of things are there. Means one cannot tell it just like a number cannot be told. See, it depends on large number of things. It is like this, that let us say outside humidity is not very high, not extremely high, but inside the room we have got lot of humid load, okay. We have got lot of humid load, then what we have to do? We have to go for it, okay. So, generally a good air conditioner will have provision for reheating and we can control the room temperature with the help of reheating. This is a very convenient method of doing so, but again from the energy point of view this is not a very good technique, because what we are doing? We are artificially creating heat load and again that heat load is being taken care of by our machine. So, we need to have a heater and to consume that heat load we have to have some sort of a oversized machine. Well, but in certain cases we cannot, we have to live with it, we cannot avoid it, all right. So, this is what is called as reheat control or reheating process or controlling the air condition by reheating process. So, it is called reheat control. Now, in certain places one can have hot and dry climate. In hot and dry climate, well, one can have the cooling coil, that means a vapor compression refrigeration system, and the evaporator in the form of a coil that can be done. Well, but whenever you are having the cooling, so it will again take out some amount of moisture from the air. So, probably you need some sort of water sprinkling in the air itself to get back the humidity. There is another technique which can be used. One can go for evaporative cooling. Okay. So, one can go for evaporative cooling. I mean, as far as comfort air conditioning is concerned, in India, number of places those air cooler, they are sometimes called resort cooler. So, those are there where with water stream one can do the cooling. There are mechanized systems also, sophisticated mechanized systems also, those are known as air washer. So, with air washer we can control the desert type of climate also very easily, because the air there is going through some sort of a spray of water which is pumped, and not only that, that water condition can be monitored either by cooling or heating the water. So, that is why I told that it is a rather bit sophisticated equipment, and with that we can tackle the desert climate or hot and dry climate.
Is water is separate source?
Can you repeat your question?
This water source is separate source we are, this water which we are spraying.
Okay. Very quickly let me draw it, so it will be clear. So, it is like this, you have got a system like this is your air washer, maybe you can have some sort of a ducting and some sort of a fan for drawing air, something like that, and you have got a pump, this is air, and this pump for spraying, number of nozzles. Okay. And here you are having cooling coil and you are having heating coil. Okay. So, you are making contact between air and water, but the water condition you can monitor. And again here one can have reheater, etc., reheater or preheater. So, those type of things are possible. So, but here as you are using water, so if any evaporation is needed to increase the moisture content of air, that is possible. Okay. But in India the use of this air washer is limited. There are certain systems, particularly the air washers are suitable for large systems. So, for large systems in certain establishment air washers are used. Okay. So, this takes care of desert climate or hot and dry climate.
There are systems in which this cooling coil is also not there. You have just water at the room temperature and water.
That is what I told, that what you are telling, that heating coil, cooling coil is not there. Yes. So, that is a very cheap system. In large part of North India we get this thing and we call it air cooler or desert cooler, that is there. But what I am telling, that one can have sophisticated good system where temperature control, humidity control is possible with the help of air washer. In fact, air washer is a much versatile machine compared to our vapor compression based air conditioning system, because its versatility, because it can go for evaporation, evaporative type of cooling. So, it is a much versatile device compared to the conventional air conditioning, but then it is more bulky, it is noisy, it is leak prone, so leakage problem, that is why it is not used that much. Okay. So, we have discussed regarding summer air conditioning. Now, winter air conditioning, I should say, is not that critical, particularly in our condition. Mostly we need heating, and in some extreme condition we need heating plus humidification. Not in all cases, but in some extreme cases we need heating plus humidification. Heating is rather easier. So, basically you need a blower for circulating the air and you need some heating, and well, for a compact system electrical heating is there, but people may argue that that is high quality energy. So, I mean heating from low grade sources like steam or hot water heating, that is also there, particularly in cold countries where I mean room heating is a must. So, they will have a boiler to have the steam formed and then it is circulated throughout the building. So, that is why they will have a centralized, for the room they will have a centralized heating mechanism, and by that the entire room will be supplied, or there can be district heating system where steam will be generated at one place and it will be supplied to number of consumers. So, that is possible, or one can have electric heater. Okay. But when heating plus humidification is needed, in that case we are having 2-3 different options. One option is water injection. That means you can increase the moisture content by injecting water. Now, if you have to do this, it is always advisable to increase the air temperature first, then inject water, because at high temperature it will have a I mean the higher ability to retain moisture. So, the process which will be there in probably some type of process like this could be, one can think of a process like this: 1, 2, 3, 4. Okay. This side is T, this side is W. So, winter air conditioning, 1 to 2, it is called preheating. Generally, if any heating is there before evaporation or condensation, we call it preheating. Then 2 to 3, water injection. Okay. If we inject water, what will happen? Water will evaporate. So, during that process, the moisture content or absolute humidity will increase, but there will be decrease in temperature. So, this process, this curve will be similar, may not be parallel to your constant wet bulb temperature curve, but it may be at an angle with constant wet bulb temperature curve. In some cases, if you control the process well, then it can be parallel to constant wet bulb temperature curve. All right. So, 2 to 3 water injection and 3 to 4 again reheating. So, in winter air conditioning, you can have these 3 or maybe these 2, preheating and water injection. So, depending on the situation, you can have this type of a process. Okay. Then one can have another option also for winter air conditioning. The condition during winter is somewhere here, our comfort condition is somewhere here. So, one can have steam injection. So, if you inject steam, then you will increase the moisture content and you will increase the temperature also. So, T and W. So, 1, 2. All right. So, this is your 1 to 2 steam injection. So, this is also possible.
These controls are very difficult, sir. Suppose I am injecting steam, then the air becomes so dry that you start getting that feeling.
Air becomes so dry.
I mean, so wet.
Yeah.
It's controlled.
Just a minute.
Steam valve, it will be ultimately controlled depending on the humidity level. So that quantity of steam is regulated.
On shift we don't
have the humidification process.
No, we don't.
Steam control, yes, so steam starts cracking when you're opening too much steam.
Okay. Actually, what you have told I could get. See, it is again just like our cooling and dehumidifying coil. Here also with a single process, I want to control 2 parameter, temperature and humidity. So, here problems will be there or problems may be there. So, what is done sometimes that or most of the time with steam injection, we also have reheating or preheating, that means temperature is controlled by at least 2 methods and steam injection is there to supplement humidity. One thing is there that for humidity one can allow a larger range for comfort feeling, all right. So, that is there. So, control does not become very critical for comfort condition, but for other applications like electronic fabrication etc., there the humidity control has to be done precisely, and there some sort of chemical processes are also used to take care of the moisture control. Okay. Not only some sort of desiccation etc. are also used for the control of moisture content. But for comfort condition, it is not very critical. In some cases, you may need to inject steam because it is giving heating plus humidification, that is possible. So, I think with this I will stop our discussion on air conditioning and we can go to other topics.